Okay, great. Thank you everybody for joining June webinar. Today we have Jacqueline Kazil. Boyu Wang is not here because he is in conference, and Tom Pike, who again the frequent contributor to the webinar, will share their amazing ABM platform in Python. In this tutorial, they will showcase Mesa-Geo, which integrates agent-based modeling and geographical information system in Python. So Tom and Jackie, please take the floor. You're muted.
Tom, you're muted.
Yeah, sorry about that. Yeah, so I'll be leading the tutorial today, but I guess the introductions first. So I'm Tom Pike. I'm one of the lead maintainers of Mesa. And then there's got my PhD from George Mason in 2019, which is where I learned about Mesa from the illustrious founder of Mesa now, Jackie Kazil. So do you want to say a few words about yourself, Jackie?
Yeah, thank you, Tom. So I'm Jackie Kazil, one of the creators of Mesa. Also went to George Mason and got my PhD from George Mason in 2023. Mesa has been in development, I believe, since 2014 now, and has had over 350 citations and more than 800 authors using it. So it's been an exciting period of growth. During today's session, I'll be watching some of the questions and trying to help Tom as he leads.
All right. Thank you, Jackie. So to get started, right, so Mesa is kind of like what we call core Mesa. And I just put this link in the chat. And we got to do a poll to fix this, but that's easy enough. But regardless, this is core Mesa is really just like the bare bones, well, sort of bare bones, agent-based modeling platform. And then Mesa-Geo is a GIS extension from it. So we did that because GIS, if you haven't messed with GIS applications a lot, have a lot of extra compute that's necessary behind that, like behind the scenes. And so we wanted to keep it separate if people wanted lighter builds. But if you want to get introduced to Mesa, we have an introductory tutorial that also can be run in Colab, right? Just like this, right? And I'll walk you step by step through it. We also have a visualization tutorial with our using a new front end called Solera, which is a great library. And then we have some other things in here. As was kind of mentioned earlier, Mesa got picked up for Google Summer of Code this year. And so that literally just kicked off, like the development phase kicked off Tuesday for us. And we got three new exciting additions, which are reinforcement learning, right? So we can link Mesa more easily to some of the reinforcement open source libraries that are out there. Vectorized operations called Mesa Frames. And that one should make Mesa significantly faster. And then the final one is cacheable Mesa, which the idea is to allow people to, if they find like a critical phase transition in a model or whatever, they can go back and replay those parts because I'll have stored the data without necessarily having to deal with rerun the computation and stuff like that. So those three things are going on. I'll always shamelessly say we are all open source. Volunteers are welcome. We're only as good as the people that volunteered. When Jackie and David set this up, they very deliberately set it up not to make it about Jackie and David and put it on like a public open forum. So at some point we can all fade away into the darkness, right? But Mesa will continue with a kind of community development. So I'll say this because I kind of stumbled into contributing to Mesa. Is that no contribution is too small, and we can use all the help we want. All right, so with that, and I'll just put it back in the chat. The final thing with Mesa-Geo is this actually is pre-release because we've been a little bit overwhelmed with life. And so like the easiest way to get there is to follow this link. If you just look at Mesa-Geo and read the docs right now, you will not see this. So if you want to follow along, you can see this. The intent is that we release Mesa-Geo 1.0, hopefully by the end of the month before before July 4th. And so and then this should more or less be what it looks like. All right. And then the one thing that's not working right now, but should hopefully, once we figure it out, mostly working, is you have this, which is you could just use Jupyter Lite, and then you won't need and then you will not need a Google instance in order to just click and open it, right? This also is using something called Jupyter Bridge, right? With the idea being that having these little books here, right, and these little buttons here is that it's easier to present to people that are not technical, because as I've seen repeatedly, right, people that are not technical get very nervous when they see code, and a lot of times they just immediately shut off. Hopefully that is not the case for you today, but at the very least it becomes like interactive documentation, so you're not seeing everything all at once and you can focus on those things that you care about. So that's why one of the reasons it hasn't been released yet, but hopefully by the end of the month we'll have worked through all the bugs, and we'll be able to release Mesa-Geo 1.0. But all this is live right now, and you can absolutely follow along. And so this is the introductory tutorial, right? So first, if you're in a Google Colab instance, right, we're going to install, and this is going to install directly from my repository in the particular branch that this code is on, which is New Sphinx, right? And then because we need some GIS data, we're going to pull in some European border, some European boundaries. As that loads, I'll say this Mesa-Geo is actually started by one of our contributors, Corvins, who lives in Central Europe. And so that's so he made this, and then we just kind of adapted it over the I guess subsequent years. Right. So this is all thanks to Corvins and his contributions. Right. So first we'll install this current pre-release of Mesa, and then we'll pull that over, right? And then we import Mesa as like the base package, Mesa-Geo, and just for ease, call it MG, right? And then Mesa-Geo.visualization. That'll just make our coding a little bit easier as well. Right. And it always takes a little bit of a second to stand up. But I guess as that loads, are there any questions or concerns? Or does anybody need some help with anything?
No, all good. And the Colab notebook is running fine.
Okay, good. All right. So what we're going to run here is a Schelling Segregation Model just on a geospatial. So if you're not familiar with the Schelling Segregation Model, looks like I have to update that link. All right, the Schelling Segregation Model was written by economist Thomas Schelling. And the idea was that when he did it, he was on a chessboard with like coins, and it says if I got it's like 8 squares around me, 8 squares around me, and if let's say if I'm blue, there's like blue and green people in this game. If I'm blue and they're green, I want at least 2 other blue people next to me, right? Or I'm gonna move, right? So I mean, 2 out of 8 is not an overly I would say needy assessment. What they found when they did this is that you could get these paradoxical results. So first, first happiness would fall like a phase transition, where about I think where the most unhappy people are the most integrated societies, and then somebody that's like very happy, and they only want 2 people like themselves, so 2 blues living in the 8 squares around them, is actually produces these highly segregated neighborhoods. So you get these like paradoxical effects where micro decisions produced kind of counterintuitive macro impact. That's generally what this is, but in this case, we're doing it with the countries of Europe. All right, so that's all installed. Right, run this. Live coding's always a little bit touchy, so if it works, I'm always excited. All right, and if you want to see where the GeoJSON file went, that's right here. Right. And so then when building agent-based models, the best way to do it in our other tutorial, our other introduction tutorial looks more like that. This one will probably get there at some point. We're just trying to explore a better way to do it now with Jupyter Bridge, so they're not as long. right? But when building an agent-based model, you want to build the pieces first, right? Like very simply, and then link them together, right? And then you grow each of those pieces together, right? So what you'd want to do typically is you create your class for your agents, right? In this case, do a Schelling agent, and we're inheriting the Geo agent from Mesa-Geo. And all these things are on GitHub. So if you ever want to look at the code, right now it's Python all the way down. So you can, so it's pretty readable to find out what's happening, right? And then we'd initiate that, right? And in this case, we're going to pass in a couple of parameters. All Mesa models require that each agent has a unique ID, right? The simplest way to do that is just to do numbers, as we'll see in a second, and then you pass in a copy of the model, like your manager, which we'll see in a second, right? There's also, in this case, the what geometry you're using course, and or CRS, which is your which I'll show you that in a second. So anyways, so we're going to pass in these parameters, right? We're going to, and so for Mesa-Geo, geometry and your CRS are required. Those are GIS criteria, essentially just saying what type of model, what kind of GIS model you're using under the hood, right? And then in this case, there's an agent type here where if you're in the minority, you get it's just a binary classification. You get a 1. If you're in the majority, you get a 0. Okay. So just to summarize, the key things you want to take away from here is create for Mesa or Mesa-Geo, create your agent, right? Has 4 required parameters: the unique ID and model, which are required by Mesa. And then for Mesa-Geo specifically, you got to pass in what type of geometry you're using, right? And your CRS, right? So now we'll scroll down here, right? So if you're building this from scratch, this is typically where you'd want to start out, or this is how you want to start. Start, either your model or your agent. In this case, I would create Geo-Schelling. We're inheriting Mesa's base model class. Is there a question? Yeah. Okay. And so then for this one, we're going to have density. So that tells us, from 0 to 1, how many of the countries in Europe are actually like occupied. All right. So that way countries can move. Right. And then what percentage of the population is going to be the minority? Again, this goes from 0 to 1. And then if you wanted to, you could export the data. Right. So these are our hyperparameters that will kind of set, our model dynamics. Right. And so then typically, and we'll talk about this stuff in just a second. All right. But now we're going to use the Mesa-Geo agent creator, right? And we're going to pass in the Schelling object, right? A copy of the model, which is just self, right? And then what your agents are going to be. So in this case, our agents are coming from this file, right? So each agent is essentially the boundary of a country in Europe. All right. So we create these. So from Mesa-Geo's agent creator, right? You can pull in this GeoJSON, so essentially your shape of your raster file, right? And then that will make your agents, right? And then as you go through these agents, so now you got a list of agents here, right? And as you go through these agents, right, then they're going to determine whether or not they should be the minority or in the majority, right? And then we'll add them to the function, right? So let's see.
Tom,
right.
quick question.
Yes.
So the agent creator, what was the method? From file. Does that only have a method for loading agents from GeoJSON?
Yes. Yeah. So this time, what? Yes. I'd have to see. Man, that's a good question. Actually, I didn't look at that because I've been so busy building out the stuff. But let's look. Because that's the benefit of this. Now, that's a good question. Right. So I always like to emphasize this point, right? It is, that's honestly, it's also, I do it to try and get people in there, right? So agent creator, GeoAgent. All right. So if you follow along, right, I just went into the GitHub repository. Again, it's all agents all the way through. or it's all Python all the way through. Here's your agent creator. And now to answer your question, Andrew, right, it can be done from files, geodata frames, GeoJSONs, or Shapely objects. So there you go. It's multi-use.
Great stuff.
Right? And this will also be in the API documentation, but there you go. Yeah. So there you go. Excellent question. Thank you. Right. And so I kind of skipped over this bit. But when we created that model, right? So just to orient you, since I'm moving my screen all over the place, here we have the Geo-Schelling, right? As the CRS coordinate reference system, right? And so this creates the space, right? That we're going to use for our simulation, right? And then as it goes through, as you create your agents, all of that just gets passed in, right? So in this case, you do, because it's spatial, like in core Mesa, you can add space in afterwards, right? And Mesa-Geo, you got to add space in up front because it's kind of a critical part of the whole thing, right? And then you can just add agents from a list, right? And then in this case, we updated those agents to give them their one attribute. Well, besides who they are, right? Which is what type of agent are they? Right. So that's what this is doing here, right? We're just updating that. So it starts out as none, and then we're just updating it either a minority or not a minority, right? And then we're making sure we add that in. Okay. So if you want to export your stuff, you can do that, right? This is just one of the features, right? Get agents as a data frame and pass it out. But I'll pass it in also as a GeoJSON, right? But I think this one, like, you can also dictate if you want something else like GeoPandas or a specific type of file, right? And then next up, right, is the step function, right? So just to kind of summarize, right, we initialized our agents, all right? And then we initialized our model, and now we're going to add things for them to do, right? I should say, well, I'll get to data collector in a second. So we're going to add step, right? So if this is a step, what's it going to do, right? So this model will terminate if all, on this particular approach, if all agents are happy, right? So they move and all agents are happy, right? Then the model will stop running, right? So you see up here, we set self is running equals true. Down here, we set self.running equals false, right? So in this case, it has a stop condition, right? And then if you want to, you can export the data. So we'll mess with that later, right? And then each step, right, it counts the agents, right? Or it determines how happy agents are as the kind of main identifier, right? So now I'll talk, Mesa scheduler, right? So this is from Core Mesa, right? This is, Core Mesa has a couple different types of ways you can do activation functions, right? The most common, probably is just the easiest. You just kind of randomize a bunch of behaviors, right? Is random activation, but we also have, we also now have a discrete event simulator, right? But we have, you could just do them in order where you don't do it, where you don't change the order every time. And there's another one, sorry, Jackie, I know what it is, like simultaneous activation, right? We have a simultaneous activation step. The hope is by December, we'll also have a network activation type schedule, right? Because Mesa does integrate network X, complex systems are adaptive networks, right? And so we also have a network space that you can work on. So we're hoping to do a network scheduler as well. All right, hopefully before the end of the year. All right, so that's inheriting that. Here we have all these agents added in, right? So first we make the agents and put them into space, right? And then we add them here, right? And then we call the step function here. So now we go back up here to our agent class, right? The one, part of Mesa's syntax is that every agent has to have a step function, right? Because that's what Mesa looks for when when the scheduler iterates through each agent or whatever agents that you're looking at, it'll iterate through this this step function, or it'll look for this step function and then action, right? And so then, since it's a Schelling model, it's pretty straightforward, right? Look at how many of your neighbors are the same, how many are different, right? And then using the Mesa features, GI or Mesa-Geo features in this case, it gets the neighbors that are around them, right? And then iterates through those neighbors to determine what type of neighbor they are, right? So since there's some empty spaces, if they don't have if there's nothing next to you, they just continue, right? If they're like you, then that's similars +1, right? Just a counter, different +1, right? And then if you're unhappy, you move, right? So this case, pretty straightforward. If the number similar is less than the number different, right? Then you look around to see if there's any empty spaces, and then you just randomly move to that space, right? So this case, it's like you want at least 50% of your neighbors to be like you. It looks like, right? And then if your number if the number of similar is greater than the number of different, then you're a happy agent, all right? And then that increases the count of how many agents are happy, right? And this would just tell you if you call this agent what their ID is. So it's just one of Python's core syntax things, right? So that's the step function, pretty straightforward. Look for your neighbors. If there's more of them are different than are the same, then you move. If more of them are the same than different, then you're happy and you stay put. All right. So play these. So that's the general setup of the model. Take a look at time. Should be able to finish this off in the next 10 minutes. 14, I guess. Right. And now we're going to build a visual. So at that point, you could just run the model if you wanted to. Like run it headless, if you will, right, and collect your data. Because this is a fairly simple model. Oh, sorry, I lost my connection. I talked too long and I lost my connection to my thing. So give me 1 second. That's annoying. I wasn't keeping track of time. Okay, so this will take a second to run again once it starts connecting. Right, but then as you get down here, as that hopefully connects soon, because I had this problem yesterday. As you get down here, now we're going to draw things, kind of create our visuals, right? So using Schelling Draw, this is just the custom one saying that if they don't have an agent type, they're gray. If they do have an agent type, we'll make them orange. Or if their agent type is 0, so that's the majority, we'll make them orange. If their agent type is the minority, right, then they'll be blue, and then you'll return that portrayal. We're going to have 2 model parameters, right? So if you remember, our 2 parameters that we pass in are density, right? So a thing between 0.1. For the love of goodness. All right, I'm going to have to open this back up again. Just give me 1 second. Okay, so hopefully this works. Unable to connect.
This portrayal dictionary, is that are the keys that are allowed in that like documented as part of Mesa, or is this part of the visualization library that you mentioned?
Yeah, so this is part of it is partially in Mesa, but if you want like more I guess more options, we just use Solera, which uses IPy widgets. And so that's, as maybe a more clear example, the portrayal is part of Mesa, but then like everything else is kind of dependent on the kind of common Mesa or common Python libraries. So like if you want different parameters, we got like slider float, you have slider int, you can have checkbox. Those are all just part of IPy widgets. So here, let me stop sharing my screen real quick so I can restart my browser.
Mm-hmm.
And then since I lost my runtime, and Google Colab does not like it when you import from when you import, it seems, from a Git repository versus like the PyPI library. All right, so now this should hopefully connect. Otherwise, I'll have to come up with something else to do. All right. Yeah, so this here, to answer your question, Andrew, if you want to know like all the options you can use, it's IPy widgets, right? Which has sliders and here's your widget list. All right. And so then you can even have, empty text boxes, log sliders, all sorts of fun things.
But the portrayal dictionary is for styling individual agents, right?
Yes. Yeah.
Okay.
So, yeah, I guess I'm really sorry. This is Google Colab's giving me such a hard time. Let me try this. Okay, there we go. That worked. All right, so now start it again. Okay, and then I feel like I didn't give you a good answer. So, when in doubt, let's go to the code. Okay, so this, so now where we at, we're in this particular branch. A better version of it will be integrated into Mesa 1 or Mesa-Geo 1.0. Right, then all the visualization is stored inside. So this is like your kind of key elements. So tile for shapefiles, roster for roster files, space agents, and then the kind of base that you need for Mesa-Geo. Right, all the visualizations are in here. GeoJupyter Viz incorporates. This is where Solera is at, and then Leaflet is where we integrate the Leaflet, which is for map visualizations. All right. And so here. Right. Okay. And so for agent portrayal, it is looks like it's just options for rendering agents in a dictionary. Right. And then let's create your stuff. Here's your color. Yeah, so that's yeah. So for portrayal, it's not overly complicated. It's literally just a dictionary of what you're trying to present. Does that answer your question, Andrew?
Well, you've answered my question by pointing me to where to look in the code to answer my own question.
That's fair. Yeah,
we're
but
good.
it is like yeah. So it is just a dictionary. There's no. I don't think there's anything more to it.
Yeah, that's
right?
fine. So,
Yeah.
and I noticed that we're on your fork of Mesa-Geo. So this is what will be released as part of 1.0 in the near
Yes.
future. Yeah. Okay.
Yep. Yeah. So yes, that is correct. All right, I'll put that link in too. All right, so you pass in your dictionary, right? I think further to your point, this doesn't allow for a lot of customization, just because it is pretty simple, right? Then we use the IPy widgets I kind of went over, right? So slider, floats, and checkbox in this case, right? So we got 0 to 1 or 0 to 0.9. If you go to 1 in this case, then the model will error out, right? And then what minority do you want to have? As you can see here, you can set, this is the type you're using. That's the default value, right? So actually this one's good point. So yeah, points. So that's your default value that immediately stops with. So this will make it go a little bit longer, right? And then whether or not, and then there's the checkbox on whether or not you want to export the data, right? So this just sets up, this whole cell just sets up your model parameters to be passed in with the visualization, all right? Now this point, now this is where you actually create it, right? So so this is, Mesa-Geo visualization, GeoJupyter Viz, and that one calls the leaflet visualization. This passes in your model parameters, and then the only measure we're doing here is happy, right? And then these are just some things you can add. Just because it could get exciting. So the GIS stuff, you can also put in what you want your center point to be and your zoom level. One of the benefits of Solera, right? So actually, I don't even need to do that, right? Is now you can just actually view the output full screen, right? You can also do the same with Solera with this little button here, right? And then we can run them off. Right, so gray is nothing there. Orange is a majority, right? And blue is a minority, right? And so because it has that stop condition in it, right? Everybody's happy. They're surrounded by people that look like them, right? And then this, oh, I guess it's still going. Never mind. And then this here is the measurement that we passed in. All right, so you can track how many happy agents there are. Right, so if you increase the number of folks, if I stop this, increase the number of folks, increase the percentage, right, and then run it again. Should run. Colab. Oh, there we go. It's actually still running. I'm sorry about that. So that is, if you run this, if you don't run it in a Jupyter notebook or a Jupyter, it actually still is. You could just you could call this without a without the Jupyter notebook stuff, and then you just get the full screen output. Let's see if I can get this to run. But Colab sometimes gets grumpy with you if you use too much stuff. Nope. Okay. Well, you wait for it to catch up. So, I guess with that, are there any questions right now on Mesa-Geo?
Yeah, so this is really interesting. I like the idea of being able to like represent geographical areas as agents. How far have you got with being able to like have agents? So it's useful to have, say, a country represented as an agent, but how does Mesa-Geo work well with hierarchies where, for example, a country might have counties in it and then agents be households, for example, within that county? Is that something that you've thought about being able to do?
So I'll say this, and this may be indicated by the fact that we're on 1.0. I don't think we have done it. I know you could put like individual agents that aren't that aren't like a geography in there. In this case, it was just the way we built the model. So you can, so if you're saying like doing a traffic model, you could put individual agents in there, but I don't think we have thought about hierarchies yet. Yeah, so you can do, yeah, so does that answer your question?
Yep. Thank you.
Yeah. And then, I mean, the other bit with GIS is that GIF gets very kind of computationally heavy. And so using things like GeoPandas and stuff, it just makes it like run slower. So I think we're also looking, just like we're looking at for core Mesa to do vectorized operations, we're gonna carry that over. You try and carry those things over to make it go faster and put some more performance underneath it. I think at some point, I think we may have talked about this in Santa Fe. We're also looking at giving options. So if you want to have like a lower level language, like a Rust underneath it, so that way certain parts are going faster and you could, do more larger models. We're looking at doing that too, but that's probably at least a year and a half. It was probably a year out maybe. So, yeah. The other bit then is another update to core Mesa is that we're updating our cell space there, so it's more like raster data, right? And that should also like help Mesa-Geo become more performant and make it kind of carry over from core Mesa into Mesa-Geo very easily, particularly for raster files.
Which is to say that the grid cells will be geo-referenced to be able to say this is, yeah, okay.
Yeah, yes. Yeah. So are there that really kind of concludes the tutorial. I'm sorry Google Colab gave me such a hard time, but I think it was switching to Jupyter Lite, so that will hopefully should be somewhat more performant. Maybe I just gotta get the higher end version. And close. All right. So that is so are there any other questions, concerns? If anybody's running the model with me, do you have any problems or issues as you're running it?